Yeah. So before I start, let me briefly introduce our institute, TRICE. So Tokai Research Institute for Environment and Sustainability, or TRICE, is actually is a new or young institute. And Tokai University, like many other universities, used to have many institutes. But actually many of these if a university have many institutes, so maybe a significant portion of them are not enough productive. So the university's goal was to merge and integrate these institutes and having few but more productive institutes. So TRICE established in line with this aim and objective. So there are three actions in the mission of TRICE to provide a comprehensive dissemination of sustainability and environmental research and education, and contributing to society through collaboration between other institutes, with industry, and also other countries, and providing a global outreach of Japan's past experiences in environmental issue and in energy related matters, and establishment of a platform for human exchange among diverse stakeholders. So since established, we initiated several projects. Majority of these projects are receiving fundings from the government. And in the first year, it was, our first project was on environmental policy analysis in Japan. And secondly, in this year, we are working on energy and finance, carbon neutral cities and society, and on circular economy. So we have a chart of a week that it's a short paper that authored, contributed by members of society. Also, members are, members of institute, members are actively involving in research, publication, journal publication, books, and so on. And also we have a discussion paper series. So we list our journal publications. For example, this year, several dozens of journal publications related to energy, environment, and other sustainability topics are we had. And then so also doing collaboration with other institutions, other universities, and societies also. So for example, this year we organized a joint conference with Oxford University and Kitakyushu University, in Kitakyushu, on ESG investment in East and Southeast Asia. So the output of it is going to be a book to be published by World Scientific. I'm editing this book. Or just last month here, we had a joint seminar with Yonsei University in Korea, and we signed an MOU between our institute and Graduate School of Environmental Finance of Yonsei University for promoting research and collaboration. So this is about a short intro, and we hope that also this is our first program with your institute, and we hope that it be a good start and we promote collaboration. So with this, let me invite Professor Zhang, Director of the Institute of Energy, Environment, and Economy of Tsinghua University, for having the opening remarks. Please. Professor, if you come here, because this is connected to, please.
Oh, it's great. Okay, thank you very much, Professor Farhat, for your kind invitation and organizing this seminar for us. And yes, so I come from Tsinghua University and Beijing, China. So I'm a professor of management science and engineering, and a director of the Institute of Energy Economy at Tsinghua University. And so now my research interest include climate economics and policy, so low carbon energy, economy transformation, and with the emphasis on the carbon pricing. So this is the main topics that I would like to share of our research here. And so I would say a few words about our institute. So our institute, call it Energy, Environment, Economy, Tsinghua University. So actually, we have a pretty substantial and collaboration before with Q University. Yeah, so we have our institute name is Energy, Environment, Economy, the 3E Institute. So actually, at the Q University at that time, there are also a 3E Institute. So, so I'm very happy to meet you, Professor, here. So so I'm very glad because I know that your professor also visited Tsinghua University and gave lectures for the Tsinghua faculty members and the students. It's a pleasant surprise for me to meet you here. Okay. So now, I would say our institute. So we have 22 faculty members. And that is including the professors and professor, associate professors and assistant professors together. So we have 22 faculty members. So I think our already program is pretty attractive. So right now, so we have approximately 30 doctoral students, and we have 20 master students, and so this is all a greater program. So right now, so we have about 10 postdoctoral fellows working with us. So this is our group, and of course, so our university, our institute is a research institution affiliated to the Tsinghua University. So we are academic research institutions. So some of the research funding from China's National Science Foundation of China, the Ministry of Science and Technology, and so they are provided funding for us to conduct fundamental and research, and at the same time, so we also work for the government agencies in terms of assisting those government agencies in formulating China's energy and climate policy. For example, so the Ministry of Ecology Environment and the National Development Reform Commission, the National Energy Administration, and the Ministry of Industry and Information Technology are also our major clients. So this is all major the business. So under the research institute, we have several research groups. So one group is on the energy planning, and the one group on the electricity system, one group on the industry, one group on the transportation, and of course one group on the climate policy and the mechanical design. So this is our group and our institute. So we have a very wide international collaborations. So with the foreign universities, for example. So we have a research program before with the MIT, and that's a 5-year research program. And right now, actually, we have a collaboration with the Stanford University, the Department of Economics. So on the emission trading system, and also we have some collaborations with the University of Carnegie Mellon in the US. And we have some collaborative ties with some UK universities, such as the Oxford, the Cambridge, the UCL. Yeah, so we have right now we have a collaborative ties with the research group at the Kyoto the Kyoto University, Tokyo University, and in Japan, of course. So we have some collaboration with Professor Xue at the Nagoya University. We met there the dean of the School of Economics, and also they organized a seminar for us. And then, so we came here. We are very pleased to be here to join the seminar organized by Professor Farhat. So of course, it's my first visit to Tokai University. Yeah, so I hope from this visit we can say a collaborative tie between your institute and our institute can be well established. Thank you very much again for your invitation, and I'm very pleased to be here, and I very much appreciate your organizing this seminar. Of course, you are warmly welcome to visit Tsinghua University again, and Professor and you, and you, the two professors. Okay, thank you very much for your attention.
Okay, thank you very much, Professor Zhang, for the nice introduction of your institute and the good activities that your institute is doing. So next, let me invite Professor Yoshino. Professor Naoyuki Yoshino is Professor Emeritus of Keio University, the former Dean and CEO of the Asian Development Bank Institute, and currently he is the Director of Financial Research Center of Financial Services Agency at the government of Japan. So Professor's speech is on ESG investment and net taxation on GHG emissions. So let me bring your slides, just a moment, please. Yes.
Thank you very much, Shirin Zhan. I visited China in my first time in 1991. And there was no expressway from Beijing to city. And there was only one good hotel, Beijing Hotel. And then I had soybean milk and then small bread. So that is my breakfast in 1991. There are so many bicycles, only 3 or 4 cars in Beijing city. So I cannot imagine so many cars now in Beijing. And in Tsinghua University, as Professor Zhang mentioned, Keio University and Tsinghua University has sister relations more than 10 years ago. And I visited the Tsinghua. And also I was teaching at Beijing University for 5 years in December. Every year I visited Beijing University in December. The difference between Japan and Beijing, China, okay, your school continues until December 31st. Okay, in Japan, we start our winter vacation around December 24, 25. So I always visited Beijing after I finished my teaching in Japan. Then I taught, I think, almost 5 years at Beijing University. Then I often visited Tsinghua and Renmin University. Renmin and Tsinghua. And my close friend is Yi Gan. He's a I know him very well for so many people. So, and also Yu Yong-din of a Chinese Academy of Social Sciences. So I know him more than 20 years. So I have so many friends, and then we can discuss seriously about the exchange rate system and economic growth. And also I helped China to start development bank of China.
Ah.
So that was my idea.
I see.
Postal Savings and Development Bank of China.
Yeah.
So in the first opening day, I was in Beijing. So that's my relations with China. So today I would like to talk about net carbon tax, and I'm a little bit critical about carbon pricing. So I would like to receive your comments later on. First, in many Western nations, people are talking about ESG or SDG. I had a conference with American economists and American policymakers last week in Japan. They are also very critical about ESG. And then their idea is very close what I'm going to say. Many rating agencies in here. I picked up 5 rating agencies. Each rating agency has a different definition of ESG. Some says looking at amount of emission of CO2. Some are looking at the number of disclosures and so on. So there's no single definition of ESG. Traditionally, investors are looking at rate of return and risk, and they didn't pay attention to anything else. So rate of return and risks are very important items. Now investors have to pay attention to ESG or greenness. However, the definition of ESG is different from one rating agency to another. Then the investors will ask one of the rating agencies, then how should they change their current portfolio to better portfolio? However, their definitions are different. Then which rating agencies you ask, they will give you different answer. So this is the empirical results I have shown. There are 2 rating agencies, rating agency X and Y. Then in here, rating agency, one rating agency company is 9, company is 6. Another rating agency 0.4 and 4.2. You can see the order. Reversed. Then the investment company A and company B becomes different. So current ESG investment will distort the optimal allocation. So that is my basic idea. Then what is the best policy? Best policy is taxation. So measure the amount of CO2 each company is exposing. Then apply same tax rate to all over the world, same tax rate based on the exposure of CO2. Then the rate of return will become RA minus carbon tax of that company. Then rate of return changes RB minus carbon tax. Then investors can look at after-tax rate of return and after-tax risks. Then they don't have to pay especially attention to greenness or ESG because tax is charged based on their carbon emission. Then investors can come back to their original rate of return and risk. However, some of the industries exposes huge amount of CO2. For example, manufacturing, chemical industry, auto industry in Japan, they expose huge CO2. Then they will complain. So I deducted greenness efforts. So I'm defining net carbon tax. So amount of carbon emission minus their greenness effort. Greenness effort means they are planting trees. They are using hydrogas or they are creating solar power. That should be deducted. Then the company will work hard to increase their greenness efforts. So this net tax will give investors, they don't have to pay attention to specifically to ESG. They can look at after-tax rate of return and after-tax risks. So that is one of my major point. The next point is about carbon first. Okay, these CO2 emissions can be now measured. One is, this is small equipment in Japan. In Yokohama city next to Tokyo, all the schools, each classroom, they have this equipment. Then in their classroom, they measure temperature and amount of CO2 emission in their classroom. So this means if you equip this small kit to all the places, even the small businesses, we can measure the amount of CO2. So that is one way. Another way is using satellite photo. That is very expensive. But these small equipments are not so expensive. Then we can measure the amount of CO2. So this is how we can measure CO2. And then, yes.
Quick clarification
Yeah.
question. Is a small meter measuring the concentration of CO2 or the emissions?
Also, okay, this is each time, okay, in the classroom, what is the temperature and what is the CO2 amount of emission in this classroom?
Oh,
Yeah.
emission or concentration.
Yeah. Yeah. So each time they can monitor. Yeah. So at school, children can look at their classroom, how much CO2 they are producing by chatting and so on. And then they are teaching children, you have to aware about CO2 emissions. So it's a very good way to teach children that the cleanness is important. Then next, I would like to talk about carbon pricing. Carbon pricing, this is the case of EU, and then New Zealand, China, Japan, all are different. And it is not the same even in the same country. The reason, I think, is the following. Carbon pricing in Japan is we set up the target level of carbon, how much each company can expose carbon. Then on the right-hand side, company B, their actual emission is lower than the maximum level. So they have the room, this blue shaded area. Okay, another company A, they exposes much more carbon compared to the target level. Then they have to reduce left-hand side amount. Then they trade. Left-hand side, company A, they expose too much. Then this way, company B has room. So they trade their carbon. So how much they set up their target, price will be different.
Yeah.
If this is higher, the price becomes lower.
Yes.
If it is lower, price will become higher.
Yeah.
So that is why the carbon prices are so different from one country to another.
Yeah.
So I am very much skeptical about this carbon pricing, and because the target level can be set it up arbitrarily, and that will create a distorted pricing. So my conclusion comes back to the previous one. Net carbon tax will be the best way to achieve carbon neutrality. So that's my presentation. So any comments, any questions are welcome. Yeah.
Okay, so let's continue then after that.
Yeah.
Okay, thank you, Professor. So this was the first part, and in the next part we are going to have 4 presentations. The first presentation is by Professor Zhang. It's on overview of China's national emission trading system. So let me play the. Yes, Professor Zhang, please. You can also use this.
Okay. Thank you very much. So, and Professor Yoshino previously gave a very excellent presentation and also raised a very interesting discussion about how to say which how to say economic policy looks good, and Professor Yoshino skeptical is skeptical about the emission trading program, and more in favor of the carbon tax. Okay. And so my talk here is about how to say the emission trading program. It's a carbon market, so it's a different the policy instruments. Actually, so I think they are talking about the carbon pricing. So there are two primary, I think, policy instruments. So one is the carbon tax, the other is the carbon market, the cap and the trade program. So and China also has adopted the cap and trade program, or the carbon market program. So and actually, I think in the year as early as in the year 20 2009, so we discussed about the carbon tax and the carbon market, and now the China, but eventually now the Chinese government want to introduce the carbon market. Why? Yeah, of course, carbon tax is a good policy instrument, and but the difficulty is how to set the rate of carbon tax. If the carbon tax the rate is too high, it's not it's kind of difficult to be accepted politically. If it's too low, so it doesn't make progress. They only have a limited effects, and also because the government is more interested in the, how to say, the government don't like have a high uncertainty about the emissions. So they want to minimize the uncertainty. So in the emissions as much as possible. So if we give a carbon tax, so now that involve high uncertainty in terms of the emissions. So the carbon market is just on the opposite. The emissions the government can determine the emissions, and the carbon tax, the carbon price is generated. Is determined by the market. So this is the different. So if we have how to say complete the market economy, the two policy instruments actually the same. It's the two sides. Is the two sides of one coin. Okay, so this is some idea. Just maybe as a quick, fast, quick response to Professor Yoshino's Mark's presentation about how to say the carbon tax versus the carbon market. So now so as a background of my presentation. So on the presentation. Okay, and so this is the trend. Today we're talking about the carbon neutrality and the carbon emission quitting program. So this is China's new climate goals. So why is call it new climate goals? Because the year 2015, China submitted China's nationally determined contribution, the NDC, to the how to say the UN CCC. So about this actually China's commitment or climate compliance, so to the international community. So those are the key elements of China's, I'll say, the national determined contribution. That is the NDC. So here we call it the new climate goals because there is an update, and the ambition of China's climate NDC has been enhanced. For example, so the first is peaking China's carbon emission before the year 2030, but the previous one is around the year 2030. And right now it should be before. And also the carbon intensity, so it's a key element of China's new climate goal. So it will be reduced by 65%, but the previous one is 60 to 65%, but right now it's more than 65. And another very important climate goal is increase the share of non-fossil fuels, that is nuclear plus renewable. So in the total energy supply to 25% by the year 2030. Right now, so it's about 70%. The contribution of non-fossil fuels, and of course, so we also would like to achieve the carbon neutrality before the year 2060. But as I know, Japan's the carbon neutrality goal is by the year 2060. Okay, it's 10 years earlier. So we also have another. So it's about the how to say it's also about the non-fossil fuel targets. So then this is the trajectory of China's energy-related CO2 emissions. So the two scenario, one scenario is about the reference scenario, and so the blue one, so is the 2060 carbon neutrality scenario. You can see there is a large efforts. That means China's ambition so has been to mitigate the CO2 emissions have been enhanced substantially. So there is a big difference between the two trajectories, and China's carbon neutrality scenario trajectory is more is generally consistent with the 1.2 degree targets, the global degree target. So now this slide gives the major measures for China to achieve the carbon neutrality goals, so including the energy efficiency improvement, the non-fossil fuel energy substitution, and also the optimization of the internal structure of fossil energy, and last not least, so it's about the carbon capture, utilization, and sequestration, and the carbon removal technology. So this is based on the outcomes of all economic model analysis, and these figures shows the transition picture of China's energy system. So you can currently, so most of our energy come from coal and the natural gas and the oil, particularly coal is still. The coal accounts for a large percentage of China's energy supply mix. But in the future, you can see the coal will be declining and replaced gradually. So by the non-fossil fuels, by the nuclear, by the wind turbine, by the solar panels, etc. So this shows China the energy system will be a near zero emission energy system. So this shows the transition of the energy system. So now this is the transition of the electricity system in China. You can see, so after the year 2045, China's grid, China's power sector will achieve net zero emission. And actually, after the year 2050, so the power sector will be a negative CO2 emission sector in the future. So this is the deployment of the CCUS and the carbon removal technology in the future, because there are still some coal-fired power plants left. So in the power energy sector, but to how to address the emission so of those coal-fired power plants, so that there is a need to install the CCUS technology. So this is etc. Also in the industry, China. The industry is a big part of the economy, and also they need some technology to address to use the use of the end of the pipe measures to address the CO2 emissions issues. So now, So, and maybe Professor Yoshino interested in this. So this is the carbon price level or the carbon tax level. This China needed needed to exercise to enable the transition of the low carbon economy to achieve the carbon neutralities. You can see the price, the carbon price or the carbon tax need to be increased step by step for China to achieve the carbon neutrality goals. So, and actually China have a different policy instruments, and including energy efficiency standards, the renewable energy feed-in tariff and the feed-in premium, the tax relief, and the subsidized interest rates. So this is the existing those are the policy instruments adopted by the Chinese government over the past 2 decades. But right now, the emission trading program is a new member of the policy family. So, and so what's the contribution of the ETS? First, the ETS can cap the emissions of the carbon intensive industry, and at the same time, so because the emission trading program also have a carbon price, generate the carbon price will also have can provide dynamic incentives. So this is similar to the carbon tax. So now, so this is give an overview of the China's national emission trading program, and so the emission trading program. So we will cover the 8 sectors, including the power sector and the main manufacturers, and including primarily the high carbon intensive industry, and so the program eventually we will regulate approximately 7,500 companies, and the total emission regulated or covered by the carbon market is about 6% of is about 70% of China's energy related CO2 emissions. So that means the big part of the China emission can be regulated. So by the carbon market is about 70% of the China's CO2 emission can be regulated by the program. Right now, the program, so at the first phase, so is output and benchmark based program, or is not a typical cap and trade. It's not a mass based program. It's a rate program, and so it's call it a tradable performance standards. So my colleague, my student, Qi Zhenfei, will give a more introduction about what's the tradable performance standards. Right now, so we have a collaboration undergoing on the design of the tradable performance standards with Larry Goodler, Professor Larry Goodler, the departments of economics at Stanford University. So you can see, so the total CO2 emission and China's total CO2 emission and the emission covered by the emission trading program. So you can step by step, the emission trading program can regulate a large part of China's total CO2 emission, and also through the program, through the capping setting of the program, so they can very much regulate the emissions of the sectors covered, all the companies or enterprises covered by the market. So now you can see that right now is the carbon price of the program. So I think right now is recently you can see the price has been rising. So right now it's about $15 US and something like that. And yeah, of course, it's much lower than the EU ETS, the carbon price of the EU ETS, but it's higher than the RIGI of the US, the RIGI programs of the US. So now last, so because I think that China's national emission trading program is just at the initial phase, and the nationwide emission trading program is at the initial phase. So over the past 10 years, much efforts has been taken so on the pillars of the emission trading program. So in the 5 cities and the 2 provinces right now, it's just the nationwide emission trading program just started. So it's just in the initial phase. So right now, the China's national emission trading program is only covered the port and the region sector. But in the future, so the sector will be the coverage, more sectors will be covered by the program. And also, so right now, all the allowance allocation, so it's a free allocation. So and in the future, so we will also consider to introduce the auction, and the data quality control is a big issue for introducing the carbon tax and the carbon market. You need a very good high quality data. So it's very important. So I think a lot of efforts needed to be taken further to secure a high quality data of the emission trading program. So now I would like to stop here, and my students Chen Fei will give a more detailed introduction of how the ETS China emission trading program has been designed. What's the benefits, the benefits, and the impacts. Okay, thank you very much for your information.
Okay, thank you very much, Professor. It's very interesting, the progress in the emission trading scheme in China. It's very interesting. So next, I'm going to present okay. So so my presentation is on another aspect of financing, mainly on financing. So since, I mean, if we want to achieve the carbon neutrality goals and the energy transition as a whole, so we need to follow different ways simultaneously. So emission trading is important, carbon taxation is important, and facilitating and introducing new ways for financing is also important. So we cannot say which one is better. So we need to consider all simultaneously, and it should be more comprehensive. So we looked at another angle, role of credit guarantee, and especially we introduced a new scheme, it's called green credit guarantee. So it's joint work with Professor Yoshino. And so first of all, unfortunately, one of the most disappointing aspects of the contemporary global economy is the low rate of investment, especially in sustainability projects. So investment is generally in infrastructural project is not enough. And when we are looking at sustainable or green infrastructure, it is still, I mean, the issue is even more disappointing. here we recognize 4 reasons that the investment is not enough. First of all, lack of long-term financing. Secondly, still various risks are associated with green project. Thirdly, rate of return is not enough. And fourthly, lack of capacity in the market actors. So one issue is that when we want to, if government wants to set right policy, they need to put themselves in a position of investor. From the point of view of many investors, environment is not priority. So many investors are still looking at rate of return and risk. So these are the 2 main issues. And if government wants to bring more private investment, any policy that can increase the rate of return or reduce the risk can automatically bring more investment. So this is the issue. First of all, lack of long-term financing, especially in Asia. Because when we are looking at the financial markets in most Asian countries, Asian financial markets are dominated by banks. Bank resources are coming from deposits. Deposits are mainly short to medium term, 1 year, 2 years, 3 years, 4 years, or 5 years. So therefore, these are not very suitable for allocating to long-term projects. And many of green infrastructural projects are long-term projects. So this means it's an issue, especially in Asia. Secondly, several risks are still existing and associated with this project that make the investors reluctant. Although, thanks to technological progress, many of these risks are going to be solved, but still risks are existing. Thirdly, rate of return is a matter. Globally, majority of the support and subsidies are still going to fossil fuels. And many of the fossil fuel companies are not taxed efficiently. So this is making the competition between fossil fuel companies and green projects or green companies very unfair. And fourthly, lack of capacity in the market actors. Many of the market actors, many of the stakeholders, they don't have information that what is green infrastructure, what is green finance, what is green investment, and investment is required for capacity building. So capacity building is important. So what we worked on, Professor Yushina and myself, is introducing a new type of a scheme. It's called Green Credit Guarantee. So credit guarantee, you are familiar with credit guarantee. So credit guarantee are public entities that these entities are existing in different countries, in Japan, in Korea, in China, in many other parts of the world, and especially for small and medium-sized businesses. So when an SME approach to bank, because in many cases, SME does not have enough collateral, so SME cannot borrow from bank. This is where Credit Guarantee Corporation provide guarantee that act as a collateral. And then thanks to that, banks or lender that see the significant portion of the risk is covered will show interest. So what we suggest is to use similar scheme for green projects. And we called it Green Credit Guarantee. So it could be used in a current available credit guarantee corporations, or a specific credit guarantee entities can be established. That when a green project approach to bank, in many cases, because of existence of risk and because of several risks that I have mentioned earlier, bank refuse to provide lending. And many of these green projects, maybe they don't have enough collateral. This is where they go to Green Credit Guarantee Corporations, that these credit guarantee corporations are public entity, or it can be private also. And then Credit Guarantee Corporation assess the risk. It doesn't mean that providing guarantee to any project. Checking the, credit worthiness of the borrower and feasibility of the project, whether this project is profitable or going to be profitable, and providing guarantee up to a certain ceiling, not fully guarantee, not 100%, for example 70% or 80% and so on. Then after that, the green project owner approach to bank, and with this guarantee, lending will be easier. But in order to have a successful and optimal credit guarantee cooperation, there are several points that needs to be considered. Because governments may bring the initial capital of credit guarantee cooperation, but government cannot support forever. Government budget is limited, and these entities needs to run by themselves and needs to be financially sustainable. So they need to charge some fee. They need to charge some fee that we call it credit guarantee fee. But how much should be this fee? If it is very expensive, that is creating another burden. If it is too low, it cannot provide sufficient funding. So we worked on calculating the optimal fee and optimal guarantee coverage. How many percent should be the optimal guarantee coverage? 70%, 80%, 90%. So we have done several works on it, and we publish a lot. And also in this book, a handbook of energy policy that I edited jointly with my Chinese co-editor, Professor Dayong Zhang. He's in Chengdu, Sichuan, Southwestern University of Economics and Finance. Yeah. So in this handbook also, we specifically allocated some chapters on green credit guarantee. So this handbook is very general, and it is providing everything, almost everything on energy policy, and a couple of chapters are on energy finance and credit guarantee. So establishment of, our research showed that establishment of a green credit guarantee scheme can shift the loan supply curve to a green project to forward. Currently, the loan supply curve to green project is backward bending. It means up to some ceiling, if increasing lending, if asked for more borrowing, interest rate will increase. And it would be very difficult to develop those green projects. But establishment of this scheme can reduce the interest rate, lending rate, and also increase the funding. But there are two major questions that need to be answered, and we try to answer. What is the optimal credit guarantee fee, as I've mentioned, to be paid by green project? Should credit guarantee cooperation provide same guarantee ratio for all lending institutions, or it should be different? Because ultimately banks are also benefiting, because in case of default, it will be compensated by government. So it means this guarantee ratio also shouldn't be same for all banks. So we have two sides in this story. In the left-hand side is the borrower, green project. It can be a hydrogen project, it can be a solar, it can be a wind, it can be a CCUS project, any type of green project. That the optimal credit guarantee fee, it means the fee shouldn't be high, shouldn't be low. And the fee should be enough for providing funding for these credit guarantee cooperation. This is one thing. Secondly, this fee should be dynamic. It means it should be depending on macroeconomic situation. When we are in economic recession, many projects, especially green project, sustainable project, they will find more difficulty for accessing to finance. So government should use it as a policy. So it means reducing the fee in economic recession so that borrowing be easier. And when passing the economic recession and entering to boom, then raising the fee in order to avoid too much lending and in order to avoid creation of bubble in this sector. So this means the fee should be dynamic. And on the right-hand side also, it means in the lender side, the ratio, the coverage shouldn't be same to all lending institutions. This ratio needs to depend on the credit worthiness of bank. If a bank is healthy, should receive higher ratio. If a bank is risky and has huge amount of non-performing loans, receiving lower. Otherwise, it would be moral hazard if we say all are same, because not all banks are same. And also, again, this ratio also needs to depend on macroeconomic situation. That when it's in boom or in recession, the ratio needs to be different. And we also worked on this matter, and yeah. So here we have the theoretical model and also empirical model that we consider that this is the objective, the policy objective. It means the minimizing the default risk ratio to green project, and also on the bank side we have the profit maximization. And finally, it's several works, but the point is that the optimal credit guarantee ratio depend on several factors, and we categorize them into 3 groups. The point is, it depends on macroeconomic variable, it depends on government policy, whether how much government wants to promote green sector. And also it depends on banking profile. It needs to be differentiated. And we categorize these variables into 3 categories. And for each of these groups, we worked on, we collected the data of banks, different banks, and we measured the credit guarantee ratio for each group of banks. For first group, we found out that the guarantee ratio is 77%. And for second group, we calculated 68%. So it means because first group is healthier, has higher level of credit worthiness, so needs to receive higher guarantee. And this is an incentive for the second group to enhance the credit worthiness. And yeah, this is also we did some robustness check, and the results show that almost both of these groups of banks, they showed the same responses into macroeconomic factors, but their bank profile, because they have different profile, they show different responses toward the policy that the government face. Okay, thank you very much for your attention. Thank you. Okay, so next, let me invite Professor Satoshi Honma. Professor Satoshi Honma is a professor at the School of Economics and Political Science of Tokai University, and also member of TRIES. So let me share my screen. Yes, Professor Honma, please.
Thank you very much. My name is Satoshi Honma, and the course is Professor Taghizadeh and Kang-san. So today I'd like to talking about how to energy efficiency and renewable energy impact carbon emissions in Asia. This is a outline of today's presentation. Okay, as you know, Asian carbon emissions have increased quadrupled over the past 2 decades. In general, regarding carbon emissions, there are 3 factors: energy efficiency, renewable energy and economic growth. The figure we consider in carbon reduction in Asian countries, we must draw attention to the heterogeneity of Asian countries. This is carbon emission per capita of the sample 25 Asian countries for 1992 to 2019. The largest emitter of the sample country is the United Arab Emirates, emits 138 times as much as Nepal, which is the smallest emitter. In light of such Asian situation, we examine the heterogeneous impact of three factors on CO2 emissions in the Asian economies, along with environmental net curve hypothesis, in which pollution increases until a certain income level and then decreases. This is well-known U-shaped environmental curve. Unlike previous studies, we use total factor energy efficiency. Previous study used energy intensity. It does not take into account non-energy inputs such as labor and capital. So we use total factor energy efficiency and apply the panel fixed effect quantile regression approach. This is main result of our analysis. The empirical result revealed that both energy efficiency and renewable energy have negative impact on carbon emissions with heterogeneous effect across quantiles. Energy efficiency exhibits stronger mitigation power at lower quantiles, while renewable energy is more influential at higher quantile. Furthermore, the coefficient of renewable energy is consistently larger than that of energy efficiency across all quantiles, indicating that expanding the share of renewables is more effective in reducing carbon emission than improving energy efficiency. So, contribution of our study threefold. Unlike previous studies using energy intensity, we calculate and use the total factor energy efficiency as a more appropriate energy efficiency index. It allows for consideration of substitutability between energy and no-energy input. And secondly, we employ a novel panel fixed effect quantile regression approach to uncover the heterogeneous effects of energy efficiency, renewable energy, and economic growth on carbon emissions. Lastly, considering the above points, we analyze the relative importance of energy efficiency improvements and renewable energy expansion in carbon reduction. Note that non-energy inputs are not considered in partial energy efficiency models. So there is a vast amount of research on evaluating total factor energy efficiency by applying DEA. Usually the model with undesirable outputs such as carbon emission also popular. However, we do not use such model because we use carbon emission. Carbon emission is taken as a dependent variable in our panel quantile regression. So to examine the determinants of carbon emissions, many scholars have been focused on three factors: energy efficiency, renewable energy, and economic growth. Many previous studies showed that both energy efficiency and renewable energy reduce carbon emissions. However, the empirical results of the EKC hypothesis remain controversial. As I said, many studies use energy intensity, but some studies use panel quantile regression. But as far as we know, no study has analyzed Asian countries in panel quantile regression using total factor energy efficiency framework. So we fill this gap and analyze the heterogeneous impact of the three factors on carbon emissions. So we move on to methodology and data. This is formal model, our DEA model. But instead of explain detail, I'd like to explain difference between partial factor and total factor energy efficiency. There are 5 countries produce GDP using energy and labor. So left figure shows partial energy efficiency indicator. So there are 2 countries, A and B, are efficient, but right figure shows total factor energy efficiency framework. So horizontal axis presents energy divided by GDP, and vertical axis presents labor divided GDP. So 4 countries except country C are efficient. This is different between partial and total factor energy efficiency. So once we calculate total factor energy efficiency indicator, so we employ panel fixed effect quantile regression. Like here, the explained variable is carbon emission per capita, and explanatory variable is total factor energy efficiency and renewable energy income per capita and its square term and control variables. So panel quantile regression is not so popular. I'd like to explain the image of quantile regression. For we said tau equals 0.5, we have the median regression with blue line. If we set tau equals 0.1, we have the green line, and for tau equals 0.9, we have the red line. So Euler's captures the mean, while quantile regression allows to analyze across different quantiles. And this is data definition measurement. Okay, we move on to empirical results. This slide shows total factor energy efficiency of sample 25 Asian countries. The most efficient country is Nepal, and the least efficient country is Kazakhstan. China is middle. And firstly, I'd like to show the preliminary result for OL's regression. The coefficients of energy efficiency and renewable energy are significant and negative. So 2 factors contribute to reduce carbon emissions. And this is our main result. The coefficients of total factor energy efficiency and renewable energy are negative. they contribute to reduce carbon emissions. Importantly, mitigation power of total factor energy efficiency is higher at the lower quantile, while mitigation power of renewable energy is higher in higher quantile. And we confirmed the equation pattern, the positive coefficient for income per capita and negative coefficient for its square term. And this slide shows change in panel quantile regression coefficient. So next slide shows quantile regression result when we set energy efficiency equals energy productivity, that is partial factor energy efficiency, and no energy input are not considered. Similar to total factor results, energy efficiency and renewable energy are also negative, but both of them has more mitigation power at a higher quantile. So, okay, let me summarize my talk. In this study, to analyze heterogeneous effects of energy efficiency, renewable energy, and the growth to CO2 reduction agent economy, we apply a fixed effect of panel quantile regression to panel data from 25 Asian economies between 1992 to 2019. The empirical result reveals that total factor energy efficiency and renewable energy have negative impact on carbon emissions with heterogeneous effect across quantiles. Energy efficiency experiences stronger mitigation power at lower quantile, while renewable energy is more mitigation power at higher quantile. Furthermore, the coefficient of renewable energy is consistently larger than that of total factor energy efficiency across all quantile. It implies that expanding the share of renewable energy is more effective in reducing carbon emissions than improving energy efficiency. The study also confirmed the existence of the environment Kuznets curve hypothesis. When using energy productivity as an energy efficiency measure, the sign remains negative, but the mitigation power of energy productivity is stronger at higher quantile. This suggests that relying solely on partial energy efficiency measures may lead to misleading policy implications. That's all my presentation. Thank you. Thank you very much.
Thank you very much, Professor Homma, for your interesting presentation. Okay, so last but not the least presentation is by Chu Shenfei. The presentation is on China's nationwide CO2 emission trading system. So let me share your. Okay, so you can use this forward.
Already started.
So just a moment.
这个评论。
Let me close this one.
Oh, is it?
Yeah.
Okay. Thank you, Professor Fahad, for introducing. And I'm very honored to be here and to share our recent research on China's nationwide CO2 emissions trading system. This work is a general equilibrium assessment of the CO2 emission trading system that Professor Zhang just introduced. And this is a collaborate work with Stanford University and Peking University. How to change?
It doesn't go.
Oh, okay. Right. Okay.
Yeah.
Okay. Yes, and this figure shows that China is already a big emitter of the world. As you can see, that China takes upon about 1/3 of the worldwide CO2 emissions. So the China's emission trading system is not only a important system in China, but also has an influence in the world. So this system is already the largest system in terms of the emissions it covered. And right now, this system only covers the electricity sectors, and as Professor Zhang just said, but it will soon be expanded to also cover important emission-intensive industries, and by then, it will more than double the CO2 emissions covered by the emissions pricing in the world. And this system is also expected to contribute importantly to meet China's climate pledge. And in this paper, we basically we built, and I will introduce that we established this multi-period general equilibrium model. And we use this model to assess China's emission trading system's benefits and costs. And we also, we did this assessment both in the aggregate term, but also in the distributional terms, like across sectors and across provinces. And we also consider a wide range of alternative specific policy designs of these systems. Sorry. And this system is called a tradable performance standard. And the name means that it is a rate-based system. It's a emission intensity-based. And what does this mean? This means that not in a classic theoretical emission trading system, the government will set an emission cap for the total emissions, and the government will also allocate the emission allowance to each firms, and the allowance allocation will be based on the absolute quantity of the emissions from given firms. But in China's way, we adopt this emission rate-based system, which means that what we regulate is the emission intensity, which is the emissions to output ratio. So actually, firms are faced with this regulation that they are faced with a given emission intensity, and they must meet this regulated emission intensity by doing mitigation, or they can also buy the allowance from other firms. So in essence, the firms are trading performance standard instead of pure like quantity-based emission allowance. So we call it a tradable performance standard. And I will illustrate the special incentives given by this system very soon. And it's tradable. So this system includes provisions for emission allowance trading across all provinces and all covered sectors. And the sectors here shows the sectors already included in the ETS marked as green, and the sectors to be included in the ETS marked as red, and these are all the emission intensive sectors that are responsible for, together with the electricity sector, they are responsible for more than 70% of China's current emissions. And in our model, we also, because we're a general model, so we also have these other sectors that may have like influenced by the emission trading system. Sorry. And I just has already introduced what's special about this TPS, and it's different from cap and trade. First, for each facility, the allowance allocation in the cap and trade is exogenous and predetermined by the regulator. But under TPS, the allowance allocation are based on the intensity standard set by the government, and they're also their own output during the compliance period. For example, for electricity generator, let's say, the free allowance they receive for the compliance period will be equal to the emission intensity standard and times the total electricity generation during this period. So it's endogenous. And also in this way, the aggregate emission cap is also influenced by the market condition. If the electricity generators increase their generation, they will also receive more free allowance allocation. And that's a benefit for them because it's free allowance allocation, and it's like the free allowance allocation has a value. So you can imagine there's an implicit subsidy to output, because when they increase their output, they can receive more carbon allowance, and carbon allowance, they can sell the carbon allowance. So the carbon allowance has a value that's a subsidy to output. And as previous studies has shown that this implicit output subsidy can compromise the cost effectiveness of TPS relative to cap and trade. And TPS is just one example of intensity standard, and there are other kind of intensity standard. For example, the low carbon fuel standard is also widely used worldwide. And there's limitation of TPS. Admittedly, like I just said, it's less cost effective, and there's some uncertainty about the actual emissions reductions it can achieve because it will be influenced by the market condition. However, it does have some attractions that makes the TPS very suitable for China's condition. The first one is that TPS can lead to lower output price because it has an implicit output subsidy. So, so the electricity price will not be influenced so much under TPS as compared with a traditional classic cap and trade system. And that means there will be less emissions leakage. And that also means that this system will put a very small burden on the consumers because China is also is still developing. So this approach is more acceptable. And secondly, this system can also automatically adjust its stringency to the economy's condition. Like if China's economy is still growing and the electricity generation is still growing, so we don't want to use a cap to stop this growth. So it has this virtue. And now let me introduce the model. It's a multi-sector general curve model, and it's also multi-period and can calculate at yearly interval from 2020 to 2035. And two special feature of this model. The first one which is also our contribution in this study. The first one is it captures the heterogeneity within a sector. For example, for the electricity sector, we have 11 fossil-based technologies and 4 renewable-based technologies. And as far as we know that this is the first general equilibrium model that has so much technological details. And secondly, we also consider some important China's institutional features. And one of special is the electricity market price and existing taxes and subsidies. And I will show that this has influence of the results. And for the data, we build this consistent data set from different data sources, and especially we use the unique data set from the Ministry of Ecology and Environment, and it's a firm level data set. And in this study, we basically consider the 5 questions. The first one is how can the system to be designed to minimize the aggregate costs per ton abated? And second, how the cost distributed across sectors, regions, and time. And third, do the benefits exist the system's costs? And second, how do the costs compare with the cap and trade system? And the final question is, should some of the allowances to be introduced via auction? So first, let's look at the system's benefits and costs. And the blue lines shows the policy's benefits, and the figure on the left shows the climate-related benefits. So it's only the benefits from the reduced carbon dioxide. And the figure on the right, the blue area, shows the benefits from the reduced carbon dioxide emissions, as well as the reduced air pollutants like PM 2.5. And that has it can improve the air quality, and this can be viewed as a co-benefit from reduced CO2 emissions. And the blue area shows the uncertainties related to the estimation. And as we can see, the benefits exist, the cost is a gray area and black line to a large extent. And we see that the benefits exceed its cost by a factor of more than 5. And if we take account of the additional air quality co-benefit, the benefit to cost ratio will be more than 25. And second, how can the system to be designed to minimize costs per ton abated? Well, admittedly, there are many ways. And here we consider how to design the benchmarks for the free allowance allocations in the electricity sector. Because China's current system has 4 benchmarks. Benchmark is the government set emissions to output ratio for different electricity generators. And we have 4 benchmarks for the electricity sector now. And we found that if we reduce the number of the emissions benchmark to one, the cost of the system will be lowered to the black line. So the current system is a blue line, and the counterfactual scenario is the black line. So the cost will be reduced if we reduce the number of electricity benchmark. But there's a certain cost associated with that, because if we reduce the number of the benchmarks, the cost of this system will be distributed more unevenly across sectors and provinces. And we found that if the current system, we calculate the standard deviation of provincial incomes, and we found that the current system has a standard deviation that is 50% lower than the one benchmark system. So there's a trade-off between the distributional goals and the cost effectiveness. And we believe that China's government has already reached a balance between the 2 goals. And this figure shows the TPS cost distributed across different sectors by showing the price change and the quantity changes. And we found that all the sectors covered by the system experience price increase and quantity and their output decrease to a medium extent. And sectors outside the coverage can also be impacted. For example, the coal production sectors will experience price decrease and the quantity decrease due to its demand reduction. And this figure shows the cost of TPS compared with a cap and trade system. And the figure on the left shows the two systems relative cost, and we see that as percentage of baseline GDP, and we see that in the years after, like here is like 2030. After 2030, the two systems cost will be more different, and TPS has a higher cost, and that's because the distortional impact of the implicit output subsidy. But in the first several years, the two systems costs are not so different, and that is because there's pre-existing taxes. The TPS has smaller impact of the price, which means the pre-existing distortions from the existing taxes, like the factor taxes, will be smaller. So that's another good point of TPS. It can reduce the distortionary impact from the pre-existing taxes and subsidies. So that makes the TPS and cap and trade's cost not so much different. And figure here shows the allowance price of the two systems, and we can still see that the TPS has a higher allowance price than cap and trade because it has a output subsidy. So the output level of the TPS is higher. That means the demand for the emission allowance is higher, and that makes the allowance price higher. And finally, we consider should we introduce some emissions allowance allocation auction, and we found that if we introduce some allowance at auction to this system, it can reduce the cost from here to the black line. And the reason is that if we introduce auction, there it can the free allowance part, which incurs some distortionary impact from its implicit output subsidy, will be smaller. So more auctioned part, the cost of the system will be smaller. So we favor that China should introduce some allowance auction at some future time. And if we use that auction revenue to subsidize, for example, the wind and solar electricity generation, it can also boost the development of the renewable energy. And that's a brief summary of conclusion. I think a key takeaway is that TPS benefits exceeds its cost to a very large extent, and the TPS cap and trade cost is not so different at the beginning, but will be more and more different in the future. So maybe at some future time, China should consider transition from a TPS to a cap and trade system. And that's my presentation. Thank you very much.
Okay. Thank you very much. So it was very interesting presentation, the general equilibrium model. So we have time for discussion and question. Yeah, we can sit from here. Okay. Okay. So Professor Ishino, please.
Thank you. I have comments and questions to all the presentations. First one is Professor Dan was talking about the carbon market and carbon trading. So that may be related to cap and trade system.
Yeah.
Okay, so that means as I've shown in my diagram, there's a cap. Then some industries have room for their CO2 emission. Another is exceeding, so that is a trading. Then your presentation about tradable performance standard, I'd like to know the clear difference between cap and trade and also TPS. Okay, so what are the differences between the two? That is the first question. Second question is, you are using generic model from IO table. Right? If there were some technological progress that would affect the entire IO table, so how did you introduce in your model for those technological progress in terms of that? And last question is, you are looking at manufacturing, services, and agriculture. Okay, if you compare manufacturing industries, characteristics are similar, but services industry are so different from manufacturing, especially in the IO table. So many countries have difficulty to create IO table, including agriculture. So I'd like to know the accuracy of those IO tables of China, because there are so many black market in services sector and agricultural sector. So if it were just manufacturing, it is good. But once you introduce services and agriculture, that table becomes very, very challenging. So that is my comment. So two of you. And Professor Farah's presentation, credit guarantee, okay, we did it for SME, small and medium-sized enterprise. That is good for credit guarantee. But if you want to apply to green finance, then what are the revenues of those credit guarantee organizations?
Yes.
Okay, if there aren't enough revenue for them, then your method may not work. What are the charges and who will be paying those?
Yes.
Yeah.
Thank you very much.
And then Professor Honma, I have a question about total versus partial FEE. So I'd like to know much more in detail what are the difference between total and partial. And then next question is, Nepal is the best, most efficient. From intuition, it is very skeptical. Why Nepal is such an efficient country compared to other countries?
Yeah.
So those are my
Yes. Thank you very much. So before we go to the next question, so let me say thanks to the online participants. If there is no question from the online participants, let me close the online session. And thank you very much for your attention and participation. Okay.